Hello friends, today we are going to start a new topic on cement, which is strength test. The cement is used in different structures and different types of loads are acted on the concrete structure. To know about the different strength of cement as compressive strength and tensile stress, it is very important to know about these. Let's discuss about this. The cement hydrates when water is added to it and cohesion and solidity is experienced. It binds together the aggregate by adhesion. The strength of mortar and the concrete depends upon the types and nature of cement. Therefore, it should develop at least a minimum specified strength if it is to be used in structure. The cement is tested for compressive and tensile strength. The unit of strength is Newton per square millimeter. Now, let's understand compressive strength. This strength is very important because in maximum concrete structure, the compressive loads are tested. Therefore, the compressive stresses are generated, and it is fundamental and basic information is required for the concrete mix design. By this test, the quality and the quantity of concrete can be controlled and the degree of adulteration can be checked. Now, let's look at the procedure of this test we should follow very carefully. All these points should be considered. A mixture of cement with standard sand 600 gram in proportion of 1:3 by weight is mixed. This is mixed for 1 minute and then water, which is P upon 4 plus 3%, is added until the mixture of uniform color is formed, where P is nothing but the percentage of water required to produce a paste of standard consistency. The temperature of water and test in the room should be around 27 degrees Celsius. The material for each 3 specimen cube is mixed separately. The mold is filled completely with cement and the paste is then placed on the vibration table. Vibrations are imparted for about 2 minutes at a speed of 12,000 per minute. 3 specimen cubes are prepared for size 70.6 mm. At the end of the vibration, keep the filled molds in moist room for 24 hours. At the end of that period, cubes are then removed from the molds and submerged in clean fresh water and are taken out for testing. The load is then applied starting from 0 to at a rate of 35 Newton per square millimeter per minute. Compressive strength is calculated from the crushing. The load is divided by the average area over which the load is applied. The result is expressed in terms of Newton per square millimeter. Now, let us look at tensile strength. It is important for concrete having low tensile strength. We have to check for minimum load that is safe as per the concrete. The tensile strength is determined by briquette test method or by split tensile test. It is approximately 10 to 15% of the compressive strength. This method at present is generally used for RHC. The tensile strength can be performed conveniently and provides quicker indication of defects in cements in comparison to compressive strength test. This test formerly used to have an indirect indication of compressive strength of cement. Now let's look at the procedure. This test is done by briquette method. The mixture of cement and sand is gauged in the proportion of 1:3 by weight. The percentage of water required is P upon 5 plus 2.5%. The mixture is filled in the briquette molds and the surface of the mold will be finished with the blade of a trowel. The briquettes are then kept in clean, fresh water and are taken out before testing. 6 briquettes are tested and the average tensile strength is calculated. The load is applied steadily and uniformly starting from 0 and increasing at the rate of 0.7 Newton per square millimeter in 12 seconds. The loading should be carefully applied to this specimen. The OPC should have a tensile strength of not more than 2 Newton per square millimeter after 3 days and not less than 2.5 Newton per square millimeter after 7 days. The strength increases when the loading rate is increased. Now, let's look at the conditions affecting the strength. It is very important to know in what condition a structure is, because these small things create greater impact. Cement is very strong at early stages if high lime or high alumina content is there. Gypsum and plaster of Paris in small proportion also tend to increase the strength slightly. But when present in quantities larger than 3%, these substances provide variable effects. Now, let's look at few questions related to this topic. The first question states that the proper size of mold for testing compressive strength of cement is A. 7.06 cm cube, 10.5 centimeter cube, 15 centimeter cube, and 12.05 centimeter cube. We clearly know that the answer is option A. Now, let's look at the second question. The compressive strength of a standard goods is 1.3 Portland cement sand mortar after 3 days of curing should not be less than 70 kg per square centimeter, 115 kg per square centimeter, 175 kg per square centimeter, or 210 kg per square centimeter. We clearly know from our previous slides that the answer to this question is 175 kg per square centimeter. Thank you for watching this video. Stay tuned to Ekeeda and please subscribe our channel.